Hello students, myself Ashish Chawla, and today we study about the Pythagoras theorem. Pythagoras theorem. The Pythagoras theorem is applicable in right angle triangle. Suppose we have a right triangle. Let's say it is a right angle triangle ABC, in which right angle at B. The side opposite to the right angle is called the hypotenuse, and the length of the two remaining sides let's be x and y. Now, according to the Pythagoras theorem, the side opposite to the 90-degree, that is hypotenuse, the square of hypotenuse square is equals to the sum of the squares of the other two sides, that is x square plus y square. This is the Pythagoras theorem, that is the square of the side opposite to the 90-degree, that is hypotenuse square, is equals to the sum of the squares of the other two sides, that is x and y, that is x square plus y square. This is the Pythagoras theorem. Now we can solve some problems using this Pythagoras theorem. The first question is, let's see, this is our right angle triangle, right angle at A. Let's say this is B, this is C. Let's say this length is 10 and this length is 8. Find the length of AC. Then find the length of AC. Now, as this is a right angle triangle, we can apply the Pythagoras theorem. Let the length of AC is x. Now, according to the Pythagoras theorem, the side opposite to the 90-degree, that is 10, that is called hypotenuse. The 10 square is equals to the sum of the squares of the other two sides, that is 8 square plus x square. So the 10 square is 100 and the 8 square is 64 x square. Now 164 is shifted to the left hand side, become negative, is equals to x square. Now 100 minus 64 we get 36. 36 is equals to x square. Therefore x is equals to under root of 36, which is equals to 6. So the length of AC, which is equals to x, that is equals to 6. Now the next question, suppose there are two poles of height 10 meter and 15 meter, and the distance between their foots is 12 meter. Then find the distance between their tops. Now, as it is given in this question, there are two poles of height 10 and 15. First of all, we draw let's say this is a ground surface. On this ground surface there are two poles. One is of height 10 and another is of height 15, and these two poles are perpendicular to the surface of the ground, and this angle is also 90 degree, and the distance between their foots, that is this distance, the distance between their foot is 12 meter. Now this is the top of this pole and this is the top of this pole, another pole. Now what is the distance between these two tops of the poles? Let's say this distance we have to find out. Now we give the names to these points. Let's say this point is A, this point is B, C and D. Now what we have to do, we draw a line from the point A which is parallel to BC. So this is a line we have to construct. which is parallel to BC. Now this line, let's say, meet the side CD at the point E. Now it is very clear that ABCE is a rectangle. It is very clear that ABCE is rectangle. Or in rectangle, opposite sides are equal. So this is 10. So the length of EC is also 10. BC is 12. So therefore AE is also 12. Now the length of CD is 15. The length of CD is 15 and the length of CE is 10. So we can easily find the length of DE, that is 15 minus 10, that is equals to 5. The length of DE is nothing but CD minus CE, that is 15 minus 10, that is equals to 5 meter. So the length of DE is 5 meter. Now the line AE is parallel to BC, therefore angle DEA is also 90 degree, because angle DEA is equals to angle DCB. Corresponding angles are equal. So angle E is 90 degree. So in triangle DEA, we can apply the Pythagoras theorem. Now the side opposite to the 90 degree, that is AD, that which we have to find, let it be X. So this is our hypotenuse in triangle DEA because it is opposite to 90 degree. So X square is equals to the sum of the squares of the remaining two sides, that is 5 and 12. So 5 square plus 12 square. So 5 square is 25. The 12 square is 144. 25 plus 144, that is 169. Now X is equals to under root 169, which is equals to 13 meter. So the distance between the tops of the pole is 13 meter. Now we move to the next question. There is a triangle ABC in which angle B is 90 degree. CD and AE, CD and AE are the medians. If AE equals to X and CD is equals to Y, then show that X square plus Y square is equals to 5 by 4 AC square. Then show that X square plus Y square is equals to 5 by 4 AC square. Now first of all we draw the triangle ABC. Let's say this is our triangle ABC. Right angle at B. Now A is the median. Median means a line which divides the opposite side, that is two equal halves, that is B equals to EC. Now the length of this AE, it is given, that is the length of AE is X. The length of AE is X. Now CD is another median. CD is median. As CD is median, so it divides the opposite side into two equal halves. Let's AD equals to BD. AD is equals to BD, or you can say that is equals to half of AB. As well, in the same way as A is median, so we can say that BE equals to AC equals to half of BC. Now we want to show that X square plus Y square is equals to 5 by 4 times the AC square. Now to find the value of X square, we consider a triangle ABE. In triangle ABE, we apply Pythagoras theorem. So The right angle is B. The side opposite to 90 degrees is called hypotenuse, that is x. So x square is equals to the squares of the remaining two sides, that is AB square plus BE square. Now instead of BE square, as we know that the BE is equals to half of BC, so in place of BE we write BC upon 2 the whole square. So AB square plus BC by 2 the whole square means BC square by 4. Now to find the value of y square, we consider to find the value of y square we consider the length of CD is y. To find the value of y square, we consider a triangle DBC. Now in triangle DBC, we again apply the Pythagoras theorem because it is a right triangle. So y square is equals to BD square plus BC square. Now in place of BD, we can write AB by 2 plus BC square. AB by 2 the whole square means AB square upon 4 plus BC square. Now we get the values of x square and y square. This is our equation number 1 and equation number 2. According to the given that we have to prove that is x square plus y square. So we have to add these two equations. Now add these two equations 1 and 2. We get x square plus y square is equals to AB square plus BC square by 4 plus AB square by 4 plus BC square by 4. Now this AB square and AB square by 4 get added. We get 5 by 4, that is the coefficient of AB square is 1 and here the coefficient of AB square is 1 by 4. When 1 is added to 1 by 4 we get 5 by 4. So 5 by 4 AB square plus, now this BC square by 4 and this BC square by 4 are get added. So again we get here the BC square, the coefficient of BC square here is 1 by 4. It is simply BC square and not BC square by 4. So here the coefficient of BC square is 1 by 4 and here the coefficient of BC square is 1. Now when 1 is added to 1 by 4 again we get 5 by 4 BC square. Now in these two terms we get 5 by 4 as common. 5 by 4. So in bracket we remain AB square plus BC square. So AB square plus BC square is nothing but AC square because ABC is also a right angle triangle. So the side opposite to 90 degree, that is AC. So we can again say that in triangle ABC, that is AC square is equals to AB square plus BC square by Pythagoras theorem. So in place of AB square plus BC square we can write AC square. In place of AB square plus BC square we can write AC square. So this is our desired result, that is x square plus y square is equals to 5 by 4 AC square. Next question is that, and there is a equilateral triangle ABC in which AD is the altitude through A, and then we have to find the relationship between AD and BD. Then find the relationship between AD and BD. First of all, we draw an equilateral triangle. Let's say this is our equivalent triangle ABC, and there is altitude AD. Altitude means which makes 90 degree to the opposite side. That is AD is 90 degree. And we know that in equilateral triangle, the altitude, median, and the angle bisector all are the same things. So this altitude is worked as a median also. So we can say that BD is equals to DC. So let's assume that the length of AB is A. So AC should be A, and the length of BC is A. Now BD is half of DC. So the length of BD is A by 2, and the length of DC is also A by 2. Now we consider triangle ABD. Now in triangle ABD we apply the Pythagoras theorem because angle D is 90 degree. So side opposite to 90 degree, that is AB. So AB square is equals to AD square plus BD square. AB square is equals to BD square plus AD square. Now the length of AB is A, that is A square is equals to AD square. The length of BD is A by 2 whole square. Now AD square is equals to A square minus A by 2 whole square. So A square minus A square by 4, that is 1 minus 1 by 4, we get 3 by 4 A square. So AD square is nothing but 3 by 4 A square, and we have to find the relationship between AD and BD. So AD square is equals to, now we write 3 and A square by 4 here, or 3 A square by 4 can be written as A by 2 the whole square, and A by 2 is nothing but BD. So 3 A by 2, in place of A by 2 we write BD square. So AD square is equal to 3 times BD square. So this is the relationship between AD square and BD square, that is AD square is equals to 3 times the BD square. Now there is one more important theorem, that is midpoint theorem. What is midpoint theorem? That is, if we have a triangle, let's say triangle ABC, and D is the midpoint of AB, and E is the midpoint of AC. Now when we connect the midpoints of the two sides of a triangle, that is D and E, by a straight line, then this line is parallel to the third side, and the length of this side DE is half of BC. That is, according to midpoint theorem, if D and E are midpoint of AB, AC respectively, then we can say that DE is parallel to BC, and the length of DE is half of BC. That is our midpoint theorem. And what is the converse of midpoint theorem? Converse of midpoint theorem. What is the converse of midpoint theorem is that, let's say if there is a triangle ABC, and D is the midpoint of AB, and from this midpoint I draw a line which is parallel to BC. D is the midpoint, and from this midpoint I draw a line which is parallel to BC. Then where this line intersects AC, that is, let's say it be E. So this point E is the midpoint of AC by converse of midpoint theorem. What is we have given that D is midpoint of AB, and from this point, from D, we draw a line parallel to BC. Then this line bisect the other side. That is, or we can say that E is the midpoint of, that is, E is the midpoint of AC. That is our converse of midpoint theorem. In converse of midpoint theorem, we have given D is the midpoint of AB, and the line from this midpoint we draw a line which is parallel to BC. So this line automatically intersect the other side at the midpoint only. So this is our midpoint theorem. Let's do one problem based on this. Let's say if I have a triangle and let's say D, E and F are the midpoints of the sides BC, AC and AB. Now by joining these midpoints, we again get a triangle. DEF. Now in this question we have given the perimeter of triangle, let's say it be a centimeter, and it is also given that perimeter of triangle ABC is given a centimeter, and let's say area of triangle ABC is given, let's say, b centimeter square. Then in this question we have to find the perimeter and area of triangle DEF. As F is the midpoint of AB and E is the midpoint of AC, so by midpoint theorem, FE, the length of FE is half of BC by midpoint theorem. In the same way, as F is the midpoint of AB and D is the midpoint of BC, so the length of FD is half of AC according to the midpoint theorem again. The length of FD is half of BC. In the same way, D is the midpoint of BC and E is the midpoint of AC. Now when we join D and E, this line is parallel to the third side, that is AB, and this length DE is half of AB. Now the perimeter of triangle DEF is equals to FE plus FD plus DE. In place of FE I write half of BC. In place of FD I write half of FD is half of AC. Correct it. FD is half of AC, not BC. Half of AC. In place of DE write half of AB. Take half common. In bracket we write BC, AC and AB, which is nothing but the perimeter of triangle ABC, which is nothing but the perimeter of triangle ABC. In this question it is given that it is A. So our answer is A by 2. So the perimeter of triangle ABCDEF is half of the perimeter of ABC, that is A by 2. Now we come to the area. What should be the area of triangle DEF? Now, as we know that the line FE is parallel to BC and equals to half of it. So, as the length of FE is parallel to BC and the length of FE is half of BC, and we already know that BD is also half of BC. So we can say that FE is equals to BD. FE equals to BD, and FE is parallel to BD because BD is a part of a BC. So because BD is a part of a BC, as BC is parallel to FE, therefore BD is also parallel to FE. So by sufficient condition for a quadrilateral to become a parallelogram is that one pair of both sides is parallel as well as equal. So in quadrilateral, now in quadrilateral FE BD, we have FE is equals to BD and FE is parallel to BD. Therefore FEBD is a parallelogram. FEBD is a parallelogram. So as FEBD is a parallelogram and FD is a diagonal, and we know that the diagonal divides a parallelogram into two congruent triangles. So FBD and DEF is are congruent triangles, and we know that the congruent triangles are equal in areas. So let's say if the area of this triangle is x, so the area of this triangle is also x. Now similarly we can also prove that AEDF is also a parallelogram, and FE divides, the diagonal divides this parallelogram AEDF into two congruent triangles. So these two congruent triangles are equal in area. If this is x, so this should be also x unit square. In the same way, FECD is also a parallelogram and DE is a diagonal. So this diagonal divides into two congruent triangles, and these two triangles are equal in area. If this is x, so this should be x. Now according to the given figure, we see that the area of triangle ABC is 4x. Area of triangle ABC is equals to 4x. Now, and the area of triangle DEF is equals to x. Okay. Now, from these two statements, I can say that area of triangle ABC is equals to 4 times x, that is x is nothing but area of triangle DEF. Area of triangle DEF. Now area of triangle ABC is nothing but B. It is given in this question, is equals to 4 times area of triangle DEF. Now therefore area of triangle DEF is equals to B upon 4. This is a very correct answer. So when we connect the midpoints of the sides of a triangle, then we get a triangle whose perimeter is half of the initial triangle, and its area is become 1/4 of the initial triangle, that is ABC. Thank you.